Hello learners, um, welcome to Naga Hema courses. It is Venkat Narayan Nalajalla standing before you. Now I would like to start our today's class number 3 with statistical independence. Statistical independence. Is my voice is audible for you? Statistical independence. Okay. Let us consider two events A and B. When we can say it is statistical independent nature, two events A and B are said to be statistically independent if it satisfies the following equation. What is that equation? P of A intersection B is equal to P of A into P of B. Let me highlight this here. Application point of view, it is very important. Here, was that equation means probability of joint occurrence of two events are said to be statistically independent in nature, and it is equal to product of their individual probabilities. That's it. Okay. Say for example, we have some condition. If A intersection B is equal to pi. What does it mean? Both A and B are mutually exclusive in nature. Then what is the probability of A intersection B is equal to probability of null set is equal to 0. What does it mean? Probability of joint occurrence is equal to 0 for mutually exclusive events A and B. Okay. Now let us enter into some more example problems. Next example problem. Example: in a deck of 52 playing cards, in a deck of 52 playing cards, one card is randomly selected. One card is randomly selected and it is not replaced. What does it mean? We have 50 number of playing cards and one card is picked up from the deck of 52 cards, and one card is not being replaced. Okay, it is not being replaced. Then determine the probabilities of A. Say for example, determines the probabilities of selection of the first one, king card. Say for example, probabilities of selection of king card. Probability of selection of king card. Okay. What is the probability of selection of king card? How many king cards we have in a deck of 52 cards? We have four number of king cards distinctly. Hence, it is given by 4 by how many number of cards here we have? Different possible combinations, 52. Hence, it is 4 by 52. Hence, it follows in reduction 1 by 30. It is the 1 by 30 is the value of probability of selection of king card. Of course, we have others, something like jack, queen, ace, any of these cards, always the value is equal to 1 by 30 because one card is being picked up. Okay. Now let us move on to the next one. So, example, what is the probability of selection of king as well as queen simultaneously? We can write like this here: probability of selection of king and queen. Here it is probability of king intersection queen is equal to probability of null set is equal to 0. Why? Because we are picking up only one card. In one pickup, either we can get a king or queen, but we cannot have both the things happen at the same time. Hence, this is an impossible event. Hence, probability of an impossible event is equal to 0. Okay, next question. See, we have to determine the probability of selection of card number 7 or spade. Probability of selection of 7, the number is 7 or spade. Here in this step we need to apply law of addition of probability. Here. Okay, I'll mention within the brackets. Here, what does it mean here? Probability of, it is simply represented as probability of 7 because it is R in the sense union of spade. It is something like P of A union B, like this here. First I am representing the formula, then we can proceed into the application. Okay, since P of A union B is equal to P of A plus P of B minus P of A intersection B. Here A represents the selection of the card number 7 and B represents the selection of the spade. By substituting this, we get in how many number of 7 we have in deck of 52 cards? We have 4. Okay, hence it is 4 by total number of possible cards 52. Then how many number of cards, spade cards we have in 52 cards? We have 13. Hence it is plus 13 by 52. Okay, then what is, we are observed, what is the probability of selection of both 7 as well as spade, intersection of 7 and spade? We have one possible such combination. Hence it is minus 1 by 13. Okay, 4 plus 13, 17. 17 minus 1, 16. We read the correction required here. The last term is 1 by 52, not 13. 1 by 52. It is correction. Okay, then 4 plus 13, 17 minus 1, 16. It is 16 by 52. After simplification, what we get here? 4 by Likewise, here. In the last class we have covered something, the addition theorem or law of addition of probability. We applied here, okay? And also here we have seen that application in the form of example problem. Okay. Now let us move on to the another example problem. First, let us quote some given data in the form of table. Okay. Now another example. Here, say for example, we have two nations. One is United States of America, the other one is Italy. And here in these two countries, some number of corona patients are being home quarantine, and some patients are hospital quarantine. Okay, that concern value is being specified in the form of table. Then we proceed with the application of total probability or application of this conditional probability in this problem. Okay, here what is this table represents here? Two nations here. What are the nations? One is United States of America, the other one is Italy. Okay, here let us mark here one is USA, the other one is Italy, the other one is some total. Okay, here what is the first row represents here? First row represents home quarantine. Next row represents hospital quarantine. For convenience, we mark here home quarantine as HMQ and hospital quarantine as HSQ for convenience. Okay. Here, what are the data here? Say for example, in hospital quarantine, we have in America we have something like 500 number of patients, corona patients. Okay, corona patients, and here it is in Italy, it is 100. And in America, home quarantine are 300 number of persons, corona persons. Okay, category persons. And here in Italy, it is 100. How many number of home quarantine in total? 300 plus 100. How much it is? Okay, 400. How many hospital quarantines here? 500 plus 100. How much it is? 600. Okay. Okay. In the third row, total, it is 300 plus 500. How much it is? 800. 100 plus 100. How much it is? 200. What is total? 1000. Okay, it is given data with subject to some corona patients. Some are hospitalized quarantine, or some are home quarantine. Now we need to first estimate home quarantine. Say for example, we need to estimate the home quarantine by using total probability. We try to obtain the value of home quarantine. Okay. First of all, what is total probability equation? Here, how many countries here? One country is USA, the other country is Italy. That means here 2 situations in quarantine. Okay. So for example, if home quarantine is treated as some A, then USA is treated as some conditional event B1, and similarly Italy as B2, likewise. Okay, what is total probability equation? Okay, we need to estimate the probability, find probability of here, how many home quarantine, H M Q. Okay, is it clear? Okay, by using total probability, how this can be expressed here? Probability of H M Q given USA into probability of USA plus probability of H M Q given Italy into probability of Italy. Now we are applying total probability. It is in the same form as total probability. Okay. Try to get the values from the given table. From the given table, what is the probability of home quarantine in America? In America, it is given like this here. It is home quarantine. That is the first row and first column coincidence 300. What is the total here in that America? 800. And hence it is 300 by 800. Okay. Is it clear? Okay, my voice is audible for you. Here, next, what is the probability of this America? Probability of this America corona quarantined persons in America, it is first column totalized amount here 800 out of 1000. Hence it is 800 by 1000. Similarly, what are the home quarantined in Italy? It is 100 out of 200. Out of 200, hence it is 100 by 200. What is the probability of this Italy? Probability of Italy, it is 200 by out of 1000. Okay, these two are like terms gets cancelled, and this is simplified to which form? The first term is simplified to which form? Something 3 by 10 plus 200 will be gets cancelled. Uh, 100 by 1000, hence it is something 1 by 10, hence it is 4 by 10, hence it is 0.4. You can also call it like 40%. 40% of the corona quarantined persons. Yeah, among the total. Okay, 40%. Say for example, another question. Estimate the probability of hospitalized quarantine. Here we can go directly by simple formula. Okay, how it is being marked here? HSQ. Hence it is probability of HSQ is equal to 1 minus probability of HMQ. How much it is? 1 minus 0.5 is equal to 0.6. What does it mean? What? 60%. Yeah, simply we can say the probability of total number of persons in hospitalized quarantine, it is 60%. Same, we can apply, we can get this value by using total probability also. We can apply the same thing, same total probability formula here for this second part in the estimation of this hospitalized quarantine. Okay, let me do that part. Then alter probability of HSQ is equal to probability of HSQ given America into probability of USA plus probability of HSQ given Italy into probability of Italy is equal to, let us get the values from the table. Probability of hospitalized quarantine in America, how much it is the figure? It is second row, first column. How much it is? 500. 500 by 800. Very good. 500 by 800. Then what is the probability of this USA? 800 by 1000. 800 by 1000. Yes. What is the probability of hospitalized in Italy? It is 100 out of 200. 100 by 200. What is the probability of Italy? 200 out of 1000. 200 out of 1000. Okay. Light terms will be gets cancelled. Light terms here also light terms will be gets cancelled. What is left over here? 500 by 1000. 500 by 1000. Hence it is, how much the value? How much the value it is? 5 by 10 plus how much here? 1 by 10. Hence it is 6 by 10 is equal to 0.6. We either this way or we can, in this way we can get the probability of hospitalized quarantine. Okay, just for easy understanding, if any clarifications like, let us have quick revision. You can have this cover topics here. Statistical events, two events A and B are said to be statistically independent if probability of joint occurrence P of A intersection B, that is equal to P of A into P of B. Okay, next one we cover some example problem, the probability of selection of some king card for 52, probability of selection of